Okay, in this video, we're going to go over inverse functions. This is the introduction part, things to know. We need to understand the basic idea of identity and inverse in mathematics in general. We're going to look at these things. Identities leave things unchanged. Inverses undo the effect of an operation leaving you with an identity. So, for example, what an identity and inverse look like if we're adding real numbers. So that's something you're pretty familiar with, right? So if we have, let me just write it with numbers. So if I have 2 plus 0, I get 2 back. So I just am left with 2. So this 0 is the identity, okay? And I could write that in general as A plus 0 would give me A. Okay, we're good with that. Or 0 plus A equals A. So any number, if you're adding A, and the same thing for subtract would work too. So this is the identity. Okay, if we are looking at an inverse, we are going to be looking at a situation like this, that we're going to get the identity. So back to our 2, if I added negative 2 or subtracted 2, which is the same as adding a negative, I would get 0, and I end up with the identity. Okay, so that's called the inverse, right? So this is inverse. So I'll write it in general. If I'm adding the opposite, I'm doing the inverse operations. A lot of times we just say opposite, but it's really inverse. If we're multiplying real numbers, that's similar. So think about that on your own for a second. See if you can know how that's going to pan out. I'm sure you've seen this before, but it might have been a while. And you probably have just done it with numbers. Maybe you didn't use the variables a lot. So if we were multiplying something, like just to go back to my little 2 again, what would I multiply 2 by to get 2 back would just be 1. Right? So to generalize that, I would do A times 1, and I would get A. And that is called the identity for multiplication. Okay, so we'll write it like that. This one's for addition. That's for addition. Okay, just so we're clear. Because they'll be different depending on the operation that you're doing, like we'll see when we look at composition. So if I divided by 2, I would get 1 back. So that would be, in general, look like this. A times 1 over A would equal 1. Remember, this is like over 1, right? And then the 1 over A is called my inverse for multiplication. And we often write that as this thing here. In exponent form, we could write 1 over A. We know that equals A to the negative 1. All right, so that's a specific notation. So be careful, because the notation that I'm going to show you next is going to be different. It's very subtle, but it's different. We want to think about real valued functions rather than real numbers. So we're thinking of the function as a whole now. So we have some new notation here. To write an inverse of a function, we actually put the negative 1 there, the power negative 1, attached with the f. it's not the same as f of x to the negative 1. So I'm going to write that little note here. This does not equal, so I'll write it really clearly. F of negative 1 of x, because that's not even f to the negative 1. It's really f inverse is what we say. F inverse is not equal to f of x to the negative 1. They're very different things. F of x to the negative 1 is the same as 1 over f of x. That's just a simple thing. You're sticking the whole function under 1. What we're talking about is an entirely different thing. Though we have some of the same properties and ideas, we're going to use composition on our functions to get the inverse. So instead of like what's the multiplicative inverse or additive inverse, we're going to look at when we have composition. So what is the identity function? The function that leaves things unchanged. So the inverse of f would be f inverse. Is f inverse, like that. We write it right like that. Two functions are inverses. If f of f inverse of x equals x, and vice versa, that has to work the other way around too. F inverse of f of x equals x for all x in the domain of the inner function. So we do have to list that out in our domain. So be careful with that, to not write f inverse like we see up here. Remember, those are not the same thing. Okay, so now we're going to look at how this works, like just using words and actions and kind of jotting down the numbers off to the side. So I'm going to give you, here's some what things that happen to f. Consider the function f described below. What must function f inverse do, and in what order? So right now we don't even have like the algebraic rendition. We're gonna write that out. But what I want you to think of is if I am inputting, this is my input here that I have. The first thing that happens to f is going to be the last thing that has to happen. So, and likewise, the last thing that happens to f is the first thing that happens to f inverse. So let's just take a quick look at that. So if we start here and kind of work backwards, if we have output for f inverse, we're going to have input, Then if we subtract 3 as the second to last thing, the second thing we do on our inverse is going to be the opposite, right? That the inverse, add 3. If we have multiply by 4 as our third to last, then we're going to divide by 4 or multiply by 1/4. Now, if we have our cube, we're going to do cube root to undo that. And I'll show you how this works with the symbols. If we add 2, then we are going to subtract 2. And then input, we end up with our output at the end. So you still end up with input first and output last. But all these things in between are reversed. They're inverted in not only what we're doing to them, like add 3 instead of subtract 3, but also the order is inverted too. So that's what I want you to see here. So for the f function, let's go ahead and write that out as what it looks like as f of x. So we have an input. So we start with there. So I just write my input x. And then I add 2. Then it says to cube, and that means cube the whole expression. Not just the 2 or not just the x, but it says add 2 and then cube what's there. Then I'm going to multiply that whole thing by 4. It's right here. Then from that whole expression, I subtract 3. And that is my output, that entire thing. Okay, then I would get my f of x. Okay, so for the f inverse, let's write that one in the pink, of x. Remember, careful how you write that. We would have our input is x. We would add 3 to it. Then we divide by 4, that whole thing by 4. Then we take the cube root of that entire thing. And then subtract 2, and that becomes our output. So it's a little different if you've never done anything like that before. And if we know these are our two functions, right, our function and our inverse, when we compose them, we should end up with just x. And that's a little bit tricky to do. I'm going to stop this video for the introduction of what it is, and then I'm going to go on to the next one. Meanwhile, if you want to, between videos, try this one on your own. Take these two functions and just put one inside another. You're going to do f of f inverse of x. You know how to do composition. So you are going to compose. You're going to take f inverse of x and put it in for x everywhere you see x in the f function. All right, so I'll see you back in a minute.